So yeah, we'll get through what we can today, and then what we don't get through, we will finish up on Monday. So good news is, if we don't get through it, I can't give you an assignment, right?
That's okay.
So I know that would be a bummer.
On Friday, yeah.
Yeah, I know you guys would be really disappointed in not having an assignment over the weekend. Yeah.
I'm not.
What are you gonna do on Saturday and Sunday with no math assignment to do?
Oh my God.
Okay, so we're gonna talk about solving linear equations. And this is something that you've done in Algebra 1 and Algebra 2 and for quite a while, but we're just gonna look at a lot of different variations of linear equations, okay? And we'll kind of start off with some real basic ones, and then we'll get into some that are a little bit more difficult. And then we're gonna talk about some different types or scenarios that could happen. So, first up, we could have a variable on one side of the equal sign. So this one should be pretty straightforward two-step equation. 2x minus 9 equals 5. Our goal is always to get x by itself, right? So if we're going to get x by itself, which one do we got to get rid of first?
9.
The 9. Yep. So it's kind of the backwards of the order of operations. Order of operations says we always do addition and subtraction after multiplication and division, but here we're kind of undoing all of that. So here we're going backwards. So here we're going to add 9, and whatever I do to one side, I always do to the other. You might have in the past draw a big line down here, right? Because that's where my equal sign is at. So that gives me 2x equals 14. And then we got to get rid of the 2. X equals 7. Okay. One thing I love about this section and equations in general is I can check every single one of my answers. Okay. I can take 7. I can plug it back in. 2 times 7 is 14. 14 minus 9 is 5. Okay, it works. Okay, so if we have a problem like this on a quiz or a test, there really shouldn't be any reason why I miss it. Am I going to look to see that you checked it? Probably not, right? But if you do check it, then you kind of get that feedback that everything's good, everything works. We could also have one like this where we get something like this. It doesn't matter if the t or the x or the y or whatever variable we have is on the left or the right, okay? We don't really care where the variable's at. And so when I try to solve for the variable could end up, if I said x equals 7, pretty common statement, and somebody else said 7 equals x, we're saying the same thing, right? So I don't care if the x ends up on the left or the right. In this case, if t ends up on the right, that's okay. We're just going to solve it the same way. We're going to subtract 2. Okay, and we get here, and sometimes we freak out when we see this. Like, okay, so I'm going to divide by negative 12, right? And then either we try to go to our calculator, or even without going to our calculator, we know that 7 doesn't divide by 12 evenly. And so we're like, okay, how are we going to leave our answer? Well, don't overcomplicate it, right? If I have 7 over negative 12, we know that's going to be a decimal. And if this doesn't reduce, the best way to leave our answer is that. Okay. Can I put it in my calculator? I mean, I guess you could, but in this case, there really isn't any reason to put it in the calculator. Okay. Is the decimal wrong? I mean, not necessarily, but what's going to happen is sometimes these decimals are going to be big, long decimals, sometimes repeating, sometimes not. And so this would be a lot more exact rather than doing a decimal, okay? So instead of doing decimals, always try to go to fractions. Now, one of the bad things is this is going to be a little bit harder to check, okay? But it's still possible. We could still check it. It's just going to be a little bit more work. than some because we got a fraction. Okay, variables on both sides. Our goal is to get y by itself. We've got a y on the left and we got a y on the right. And so what I would probably do here, okay, and there's more than one way to go about solving this. Which y would be better to move? The 2, right? And what that does, because it's a positive 2y, we're going to subtract it. That keeps my y's positive. Now, and you've probably done this throughout the years as you've solved equations because we've done a lot of them. As I do this, if I'm going to move my y's to the left, I'm going to bring all my numbers to the right. So y's are coming to the left, so my constants are going to move to the right. Just really be careful of your signs. Signs are probably the most missed thing on problems like this. Negative 30, because you got a minus sign in front. Negative 30 plus 6. Negative 24. And then we can just divide by 3. Negative 8. And that's our answer. Hey, if I were to check it, I'm not going to check every single one of these today, but if I was going to check this one just to have a couple of them that we've checked. Five times negative 8 would be negative 40. Negative 40 minus 6, negative 46. On the right-hand side, 2 times negative 18, or negative 8 is negative 16. Negative 16 minus 30. Negative 46. Okay, and there's my quick check. Both sides are equal. Okay, if both sides are equal, that's good news, right? That's what we want. If one side is not equal to the other side, then we have done something wrong. Okay, and so right there is just another great example of why we want to check. Okay. To kind of go along with the last one, this one's very similar to the one we just did. 2x minus 7 equals 6x plus 17. Okay, and what I would say here is just get in the habit of, it really doesn't matter. If we're doing an inequality, and we're going to do inequalities later in the chapter, then usually we want the variable on the left, okay? But with an equation like we have here, it really doesn't matter. So if I want to move the 2x, I can move the 2x. If I want to move 6x, I can move 6x. Which one would be better to move? Should we subtract 2 or subtract 6? Probably subtract 2, okay? If we can keep things positive, that would be the better way to go about it. There's nothing wrong with subtracting 6. That's not a wrong step. You have a couple of different options here. And because I'm moving my x's to the right, everything else is going to go to the left. So we got to move 17 over here. Okay, once again, signs are really, really important here. Negative 7 minus 17. And then we can divide by 4. Okay, and it's okay to leave it like that. I mean, if you want to rewrite it and it makes more sense to you to rewrite it like this, then you could just flip it, and we call that the commutative property, right? Where we can flip sides. It's actually the reflexive property because there's no sign in between. There's no addition or subtraction, but it's kind of like the commutative property, I should have said. But the reflexive property says it doesn't matter which side those two things are on. X equals -6 is the same thing as -6 equals X. Okay. Now I'm going to give you a big, old, nasty equation. Okay, so we keep adding a little bit more to it. We had a variable on one side, we had a variable on both sides, and now we have a variable on both sides with some parentheses. Hey, and we saw a little bit of this when we were simplifying expressions in chapter 1. What would have to be our first step here? Parentheses. Okay, and what are we going to do with our parentheses? What's the word we're looking for? Distribute, right? We distribute all the time. Now, on the left side over here, if there's no number directly in front of the parenthesis, what number is that assumed to be? 1. Okay, so we're assuming this to be like a -1 right here. So that's the number that we're going to distribute. Okay, and just take it one step at a time here. So 18 is going to stay 18. -1 times 3n, -3n, -1 times -5. Positive. Okay, same thing over here. We're going to take the -4, and we do want to keep that negative on the 4. Okay, it's another thing that we've seen that a little bit, not just the 4, but we want to distribute a -4. So the 11n stays 11n, minus 4n, minus 12. Okay, so parentheses are gone. That's got to be my step 1, and you can do both sides at the same time. Okay, after we get rid of parentheses, next step, what do you guys think? Combine like terms, okay? If we have anything on either side that we can combine, we're going to combine them together. So let's look at the left side first.
18 and 12?
Okay, not yet. Because are 18 and 12 on the same side of the equal sign?
Nope.
No. Okay.
18 and 5.
Yeah.
11 and 4.
Okay. The 11 and the 4 is good. Okay. So I can combine these two together and the 18 and 5 together. Okay. This one has an n. These two don't. So those two combined together, this one can't. Okay. So on the left-hand side, we're going to have -3n plus 23. Okay. And I'm going to tell you right now, this is a very common mistake on an equation is I'm just combining these two together, right? I don't want to subtract 5 from 18 because they're already on the same side. If they're on opposite sides of one another, I'm going to do the opposite sign, right? I'm going to subtract it. I got to move it to the other side. But if they're already on the same side as one another, we're just putting them together. We're just making our equation smaller and simplifying it, okay? Combining like terms. And then, like we said, same thing on the right, 11n minus 4n. We're just straight subtracting those two. 7n minus 12. Okay. And now it's very, very similar to the one we just did not too long ago, right? We've got n's on both sides. We've got to get our n's together. Now, what would be the best move next?
The ends.
The n's, okay. Which one would we rather move?
Add the 3.
Add 3. Yeah. Okay, so if I move my n's to the right, that means I got to move my numbers back to the left. And notice I'm getting rid of the things that are canceling out. As we start moving things, we should have things kind of start to disappear. Yeah, so this, obviously 35 doesn't divide by 10 evenly. There's a couple of different ways to write our answer here. If we go back to what we said just a few minutes ago, if it was me, and kind of what I would prefer is just leave it as a fraction, but leave it as a simplified fraction. So what's something that would go both into 10 and 35? 5. Yep, we can take 5 out. So if I take 5 out of each one, that would leave me 7, 2. And that would be my simplified fraction. Okay. If I wrote n equals 3.5 here, is that okay? Yeah, it's the same thing. Okay, and I don't have necessarily a problem with this kind of decimal. The issue is when we run into like repeating decimals and big long decimals, that I would rather not write an answer as a decimal. So I would probably just get in the habit of always writing your answer as a fraction. Okay, you could do 7/2, you could do 3.5, or you could do 3.5. They all mean the same thing. Okay, but it's the ones where we have repeating decimals and things like that that throw us off. Okay, so I probably would prefer this, but there's also nothing wrong with 3.5. And your calculators do a pretty good job of changing those back and forth from fraction to decimal or vice versa. Yeah? I think 16. Yeah, 9/16, which is kind of weird. I don't know why I don't know why they don't just keep it on groups of 5, but they don't ask my opinion, so.
I was.
You would? You would trust me? Yeah. Thanks. Appreciate it. She's lying. You wouldn't, Ella? You wouldn't? No.
What's the question?
Would you trust me to make decisions if I was running a school? Oh my, she had to think about it.
I feel like 50-50.
Oh, okay. I haven't done enough to deserve your confidence, huh?
What? I'm being honest.
Being honest is sometimes not the way.
Okay.
So who would you trust then? What teacher would you say they would be?
Probably
Mr. Moss.
Oh,
Mr.
Coach
Whitney.
Warner. Mr. Whitney.
Okay.
I would not trust Mr. Whitney.
He said that he's getting a cure for cancer.
I would not trust him.
You believe it?
He was serious.
Yeah.
Sometimes they're working on it.
I would trust Mr. Kimke.
Oh, Kimke gets the notch above me?
Oh.
Wow.
I think she's joking.
Listen, I was just joking around, okay? I regret my decision. I'm sorry for saying that.
It's okay.
I would trust you.
I'll forgive you. Just this once, though.
I would trust you.
Appreciate that.
Mr. Cookie.
Okay, here we go.
Okay, I'm gonna trust you. Okay, well, I'm gonna trust you more.
Would you trust me?
No. I would make every Wednesday be a Roblox party.
Kind of like the last one, we're going to distribute. Get rid of the parentheses first. Okay, then we look at each side individually, see if there's something that we can combine. So over here, 11 minus 5. And there's a couple different ways that you could write that. We could go 5k plus 6 or 6 plus 5k. Order doesn't really matter. I always kind of like to put my variable first, but it doesn't have to be that way. 3k minus 6k. What would that be? Negative 3k. Okay. Just really be careful of your signs. Can't say that enough. Okay. Now that we've combined like terms, now we got to start getting our k's together. Which k would be better to move? The 3. Okay. So add 3k to both sides. And then subtract 6. It's a good question. And so I kind of threw this one at you guys just to see what would happen here. 6 minus 6 would be 0. Can we divide by 8?
Yes.
Yeah, what would it be?
Zero?
It would be 0. Is 0 a number? Yep. Can we get an answer of 0? Yeah. Okay. So it's okay. K equals 0. Sometimes we do freak out though. When we get 0, we think, oh wait, I can't do that. I can't get an answer of 0. You can, okay? It's not very common, right? We don't see it very often. What you can't do is we can't have 0 in the bottom of a fraction. So if it was 0k equals 8, and I tried to take 8 divided by 0, that wouldn't work, okay? And we'll talk about that here in just a little bit. But if I take 0 divided by 8, we can do that, but it's still 0. If I have nothing and I try to divide it into 8 pieces, I still have nothing, right? And so that's what happens when we have 0. Okay. We're going to see a few of these. Everybody's favorite. Fractions. Yeah. Exciting, right? Okay. Right now, this equation looks pretty intimidating, right? I don't have Halloween. Everybody agree? Fractions intimidating? Not my favorite? Right? Except for Clea. She said, yay, fractions.
Give her a bunch on the test.
But what if I told you that everybody in here, you could do this problem probably without even a calculator?
Yeah, but I don't want to.
But if I showed you this method, I think you would probably prefer to do that rather than a calculator. And I'll show you why. Okay, we'll see. Maybe not. Okay.
Some people can.
But I think every one of you could do this without a calculator. Okay, could you check it with a calculator? Sure. But here's how we would do it. Okay, so first thing, anytime we have a fraction like this, or a fraction in our equation, we're always going to look at the denominators. Okay? We got a 5, we got a 4, and we got a 2. And so what we're going to look for is you guys remember what that stands for?
OCD.
Least common denominator. Okay, LCD. Okay, least common denominator. Okay, it is the lowest number that all 3 of my denominators go into. So I got to find a number, one number, that 5, 4, and 2 all go into. 20, yeah. Yeah. What would be the best way to get that number? Yeah, and one, multiply things together, right? And so sometimes people will say 5 times 4 times 2. That would actually give me 40, which is a denominator. It's just not the least or lowest common denominator, okay? 20, all of those actually go into 20, okay? If you did 40, 40 would be okay. But we want to pick lower numbers if we can. So 20 is our LCD. Okay, and we're still talking about doing this without a calculator. Do you think I could multiply all these together without a calculator?
Yes.
Yeah.
Yes, I think you can, okay? Now, it's going to take a little bit of math here, right? A little bit of basic addition, multiplication, division kind of thing here. But 20 times 1 is 20, divided by 5 is 4. That's it, okay? So we multiply by the top, divide by the bottom. That becomes 4x. Okay? Then we're going to put a minus sign, keep the minus sign in between. We have to multiply 20 by everything, okay? We're basically distributing the 20 to everything, okay? Whatever that LCD is. Now this one might be a little bit harder. So here I'm going to make it easier. Yeah, Ella?
What if it's like 20 divided by like 13?
It won't be because it's the least common denominator. Every number that you get will simplify.
So like, when we do this, we're never going to have a decimal. Or like
You should not. Nope, as long as you pick the right least common denominator. Yep. Okay, now you have two options here, okay? One I think is easier than the other. So I can do 20 times 3 divided by 4, but then we got a little bit bigger number. So you could also do it the other way. You could go 20 divided by 4 first, which is 5, and then multiply by 3, which is 15, okay? But if I did 20 times 3 would be 60, divided by 4 is still 15, okay? But in that case, I like to divide first because that gives me a smaller number rather than getting all the way up to 60.
Wouldn't 20 times 1 half be 10?
Yep, and then the next one. 20 times 1 is 20, divided by 2 is 10, or just half of it, right? If you think of it like that.
And then 20 times 1?
Yep, still got, even though this is not a fraction, we still got to multiply it because everything has to change, right? Okay, now if I gave you the option, I said, you can either solve this equation in red or you can solve this equation in black, what are we going to choose?
We're going to do black.
Probably the black one, right? Because that one looks pretty intimidating. But guess what? These two equations are exactly the same thing, just a little bit different format. It's kind of like 1/2 and 0.5 are the same thing in a little bit different form. These two are in the same form, just a little bit different, okay? So now we can solve it. X's are gone, 20s are gone. Okay, now when we get to the end, to kind of go back to your question, Ella, is can we get fractions or decimals at this point? Yeah.
Yes.
Yeah, okay. As we're just changing our equation, we shouldn't, but now when we get to this point, we might get a decimal or a fraction. Okay, is there anything that goes into both 35 and 6?
No.
No.
1.
So, 1, yep. But that didn't help us. So, that's my answer. Okay, and just to kind of go back to